This is a vlog, perhaps interesting, perhaps not. Anyway, it is a circuit of a timer, and not a timer made in a digital way, but in an analog way. So using the RC time of electrolytic capacitors that send their voltage into a transistor, and in the collector lead of the transistor there is a relay, and when the capacitor is depleted the relay switches. And I will give the link to the original schematic in the description, the text box. It didn't work, by the way, and only on one position, and it is the 33-minute position, and I'm more or less sure, absolutely sure, that the capacitor there is more or less bad. Not more or less bad, but completely bad. So I'm gonna test that. It looks as if it was made in the Stone Age by Fred Flintstone, but anyway, it's a very good working circuit, and I've used it for approximately, say, 3 years till it, or 2 years by the way, or 2 years before it showed only on this position, the position of 23 minutes, a flaw. Anyway, so I have to search out where on this time switch. This time switch switches in all kinds of capacitors, not all kinds of, but when I say all kinds, I mean different values of capacitors that will give their charge via a resistor to a 3-stage Darlington, or perhaps a 4-stage Darlington here. This is the first transistor, second, third, fourth transistor. So as far as I can remember, I had to use such a Darlington to make a very long time, so make the circuit very sensitive. And that's the reason why you find here that even after approximately 5 hours and 45 minutes the relay switched. So that was more or less all to tell. Thanks for watching. It's a vlog, so I want to refer to the earlier schematic on my YouTube channel. I'm gonna test all these capacitors, and when you make such a analog timer with the help of all kinds of capacitors, it's important that there is no leakage. And then I mean current leakage, and that means in the ideal situation the switch that switches all these capacitors in has to have a very low internal capacitance. This is a cheap switch. It also worked very properly, so no problems with that. And furthermore, the whole circuit is very, very simple, and you can find on the World Wide Web, on the internet, many timer circuits that are made in this way. And then especially in the 1960s and the 1970s, because especially in the 1960s digital chips, so chips that could count, say a divider chip dividing 10 times or 30 times, were not very easy to find, and were also very expensive. Say a 10-by-1 divider chip. And that's the reason why in the 1960s you will find, and even in the 1950s, when there were no chips at all, and I mean silicon or germanium transistors and chips in the 1950s, this was, say, a kind of classic way to make a timer circuit. And then, of course, with a radio tube. Here it's made with transistors. And when you study circuits on the World Wide Web, in old books about tube circuits, they often use here a tube or two tubes, and the RC combination is connected to the grid of the tube. So on a certain moment the capacitor gets depleted. That means that the voltage on the steering grid of a triode, and a triode with its relay in its lead, that is responsible for the current, is driven. So that's a plate lead. That's what I wanted to tell. The relay is often connected in the plate lead, so to the, say, to 200 volts or so, and then the relay is in that plate lead, etc. Anyway, that was more or less all to tell. I have made here a stabilized power supply, and that's of course important, because when the voltage to this 4 transistor stage is not stable, that will have a serious effect on the time. So the question whether such a simple setup can be used to get to more or less precise times. And here you see 4 minutes, 6 minutes, 12 minutes, 30 minutes, 45 minutes, etc., etc. And these values are more or less approximate values. Say there is a tolerance in 5%. That has everything to do, of course, with the tolerance that electrolytic capacitors have in this case. So when you make such a circuit, it's an analog timer, not a digital timer. You have to search for yourself the different effects of all these timer capacitors. Could be that there is a spread in tolerances in these capacitors. That's more or less the common problem. But when you say use a clock or a stopwatch, you can surely find out with such a simple and primitive circuit the more or less exact times when the circuit switches on or off. That's also an issue. I've used here a relay, a 12-volt power relay, but you can also use this circuit to switch something off, and in that case you have to use the other contacts on the relay. Say the contacts that switch the relay off after a certain time. Anyway, thanks for watching. More or less all to tell. A lot of sloppy wiring. Doesn't have to be a problem in this case, though when the wiring is extremely sloppy, there could be leak currents that have an effect on the analog timing. Many circuits of this are, by the way, on the World Wide Web. RC, so resistor collector, capacitor timer circuits. Every RC combination is responsible for a certain time, and that doesn't have to be say in the minutes range, but also RC oscillators are made and are used that work according to the same principle.